Hey everyone, good morning and good evening. Thank you so much guys for joining in today. Welcome to Edureka Masterclass. And today's session is an interesting session guys. We are going to do a COVID detection using data science. And as you know, COVID is something which has affected everyone around the globe. And we'll see the application of data science into this detection. Now, this brings us to the concept that data science. So, as you know, data science is something where we use the data and perform the analysis on top of this data. Now, this time you're seeing where I'm going to do the COVID detection using data science. And you might have seen in the other webinars where I'll perform a prediction using data science, which means data science is a technique, guys, and it can be applied to many domains. And today we look into one healthcare domain, which brings to the point that by learning this data science, you not only learn how to become a data scientist, but also you will be able to work in various domains as well as perform various responsibilities. You can work as a data scientist, you can work as a deep learning engineer, you can work as a machine learning engineer, natural language processing. The opportunities are endless. So wherever, whichever the company which is using the data, that's where you will be fit in as a data scientist. My name is 𝐂𝐤𝐿𝐿 and I'll be your instructor for today's session. Okay, let's continue with our today's agenda. What do we have for today? Now, today we'll understand the basic concept of data science, and we'll also look at one of the branch of data science, or I can say like one of the technique to perform the data science, that is called as deep learning. Because while working with COVID detection, so we will be working with image data. So in order to work efficiently with image data, we'll make use of convolutional neural network. So let's see and let's look at what do we have for today's agenda. So as part of today's session, we'll understand why CNN, what is convolutional neural network, how can we process the image using convolutional neural network, and how can we use CNN for COVID detection. This is followed by a hands-on session. Okay, so this is the agenda that we have for today. So there's no expectation that you have to be expert in any programming language. I'll be sharing you at a high level so that you can follow along with me. So let's see what and why do we have to use the CNN. So this CNN is a topic under deep learning where you'll continue in your data science journey. Once you complete the machine learning, then you'll step into the convolutional neural network. So when we talk about convolutional neural network, here in this convolutional neural network, this is actually one of the variant of artificial neural network. Now in the scenario of artificial neural network, we'll have the input layer, we'll have the hidden layer, and we'll have the output layer. Now just to help you correlate, just think about our human beings. Like we have the sensory organs through which we perceive the senses, isn't it? Like we perceive the outside world with touch, feel, and everything. So smell and like using our sensory organs, we get the inputs from the outside world, and then we are going to send that input to our human brain, and our human brain will do some kind of complex calculation and tells us, okay, do this thing. That's how our human brain work. And in the same way, my deep learning neural network is going to work. It will have the input layer. Through this, I'll receive the input. And once the input is received, it's going to do the transformation on the data set. Since I'm talking from the computer perspective, I'll say transformation, but it's going to be processed. The data will be processed in my hidden layer. And then once the data processing is complete, I'm going to send the data to my output layer where the output will be given out from this neural network. Okay. So this is the flow as what happens in the scenario of artificial neural network. So the core concept of building this neural network, because we want to simulate the way our human brain is going to work. Because as you know, we humans learn a lot and we have a lot of ability in learning. We can distinguish, we can build a rocket to the space. So we have a lot of ability and we want to give the same ability to the computer in analyzing the data. And that's why we have set up this relationship, or we have set up this architecture for artificial neural network. Now talking about artificial neural network, we are going to send the image. Just like we humans understand from the pattern, the artificial neural network is going to look into the data, input data, understand the pattern, and gives us the output. Okay, once I've understood, this is how the car would look like, or this is not a car, and so on. Now, while working with these kind of network structure, one thing that we are going to face is the issue of dimensionality. So suppose if I have a image of car, okay, let me So if I have a image and if I have a car over here, okay, this is one car, and if I have one more image and if I have this car image over here, so in the scenario of this artificial neural network, it is going to treat this car and this car as different, even though both car would mean the same thing or both car looks like the same. So this is the disadvantage that we face while working with artificial neural network. So in order to mitigate this, we come up with another kind of neural network that's called as convolutional neural network. Now, using this convolutional neural network, what we would do is we are going to identify the patterns in a much more effective way than the artificial neural network. And that is the reason we prefer to use this convolutional neural network. So using this CNN, I'll identify and I'll recognize the pattern that is present in a given image. And once I recognize the pattern, I'll be able to understand more about the image in an effective manner. Now, when I talk about this CNN, so the full form of this CNN is convolutional neural network. Now here, while working with this convolutional neural network architecture, so the data will follow through multiple layers. It starts with my input layer. Then on top of this, I'll perform some kind of a mathematical operation that's called as convolution. Now I'll apply the convolution, and as a result of this, this is the outcome that I'm going to get. And I'll apply another multiple layers of my convolutional neural network where we call it as pooling layer. Then again convolution, pooling, convolution, and at the end, we'll have the artificial neural network to help us complete the process. So for your understanding, you can just think that for a given input data, the data will flow through multiple layers so that it can understand the pattern in a much more effective way. So as the data flows from input layer to the output layer, it's going to learn the patterns. Each layer is going to learn the patterns. And at the end, I'll have the respective output layer, which will help me to classify what is the given image. And this is the importance of convolutional neural network and how the architecture would look like. Now, when we talk about this convolutional neural network and any architecture in general, guys, as you might have seen, so this is the data which is closer to real life. And these applications that you see, okay, what is present in an image, these applications are closer to the applications which we use it in our day-to-day life. So if you open up your Google Lens and click a photo, the Google Lens is able to identify what is present in that image. Or if you upload your person's photo, like if you upload your friend's photo in your Facebook account, the Facebook is able to say, okay, to whom this face would belong to. And to implement all those things, they have actually used convolutional neural network. Since this is a topic which is in high demand, which is used in current application, which we as humans, we are consuming, which is affecting the way that we interact with the outside world, you have to follow a structured learning path when it comes to learning so that you'll have the success in this skill set, because these are the skills where you can learn and work as a data scientist or work as a professional. Now, when I say structured learning approach, it's a learning approach which has been designed by industry experts who and which will help you to progress from beginner to an expert by the end of the program. Now, this data science with Python certification course follows a structured learning approach, where in module 1, you'll have an introduction to Python. And from the day 1, you'll begin with the hands-on sessions. And in module 2, you learn about how to work with the files and sequences. And as you progress in module 3, you learn about functions, OOPs, modules, errors, and exceptions. And in module 4, you learn about NumPy, Pandas, Matplotlib. And in module 5, manipulate the data using Pandas library. In module 6, you learn about machine learning with Python. And as you progress, you learn about the advanced concepts like dimensionality reduction, association rule mining and recommendation system. And as you progress in the module 9 and 10, you learn about reinforcement learning and time series analysis. And as you see, this is a structured learning approach where you'll begin your learning journey as a zero, the person with zero knowledge about Python who have never done any coding in their life. And by the end of the 10th module, that is by the end of this program, you'll be someone who knows what is machine learning and how to apply the various techniques of machine learning on a given data. And you'll be able to achieve it from this structured learning approach, where an instructor will be with you in every step of the way to help you progress from beginner to an expert. And along with that, you'll have the 24/7 learner support by Edureka. Okay, now as we progress in today's agenda, so let's see how the data gets processed in CNN, guys. Now, when I talk about image processing CNN, so first we'll have a convolution layer. Now, this convolution is like the application of filter. So as I mentioned, I'll like the data gets processed through various layers, right? So in such various layer, one layer is called as a convolution layer. Now, in this convolution layer, you are going to select a filter. So this is a filter. You're going to select an example filter. And once you select a filter, this is the filter that I have selected right now. See, this is just an example filter. Let me pause the animation. Okay, so if you observe right now, this is the filter that I have selected, and I am placing this filter on top of my image. Now, once I place it, just take the dot product between the filtered region and the selected region. And if you take the dot product, now you'll see the output as -15. So you can calculate. So just -1 into 75 plus -2 into 80 plus -1 into 80. So likewise, go ahead and do the calculation, and I'm sure you're going to get the output as -15. So that is what is happening in the scenario of this convolution layer. So it's a simple layer where I'm going to place on top of my input data. I'm going to translate, or I'm going to change the pixel intensities. Now, I know this might sound very new to you, but just think about it, guys. I'll give you an example. When you open your mobile phone and you'll take a selfie. Now, once you take a selfie, what do you do normally? Obviously, you want to share it to your Instagram handle, or you want to share it with the world. Now, before you do that, what is the next step that you do? I'm sure like everyone can relate with me. So one thing that you do is you are going to edit the image. You'll apply some special effect on the image so that you highlight yourself in the image before you share it to someone else. Now, in the same way here, when you do the special effect, or when you edit your image, what is happening from the science, or when I say technical side, is you are changing the pixel intensity of each and every pixel in the original photo. And in the same way, when I apply a convolution layer, just imagine, guys, I have my original filters, like original pixel value as 80. Okay, my 80 was the original pixel value over here. Okay, now this 80 has been changed to a new pixel value as 5. See, that is what is getting changed right now. So which means it is applying some kind of a special effect on the image. Well, the reason this is happening is just like we apply the various filters to make ourselves like looking good in that image, in the same way the program is going to do this so that it can learn better and identify better with the given image. So you'll have a convolution layer. On top of this convolution layer, along with that, technically speaking, we have a padding layer to ensure that we have the same dimension. We also have a pooling layer. This will act as a summarization of the feature learnings that we have. Now coming to this pooling, I have two kinds of pooling. One is max pooling and the another one is called as average pooling. Okay, so we'll apply all these layers so that my program will have the ability to identify what is happening in a given image. Okay, now that you have the overall understanding about this convolutional neural networks and various layers, guys, let's do one thing. Let me give you a glimpse as how we would normally implement this solution. Okay, so I'll not go too much in depth since most of you are beginners. So I'll give you at a high level what is happening, and if you require more information about any step, just let me know. I'll provide you more information as well. So this is the link. So here I'm just going to get the data. So I'll import the warnings, and I'm just getting the data from my Dropbox. And once I get the data from the Dropbox, just observe I'm using the NumPy, Pandas, Matplotlib library, which is the same library which you have seen earlier in my slide when I talked about the structured learning. Okay, so I'm importing those libraries. I'm using the Pandas library and reading the files that I have with me. Okay, next, once I do it, Here I'm just setting the variable names, which is the basics of Python. I'm creating the variable names and assigning the values. And after that, I'm just going to do some data transformation where I'm going to create a folder for me. So in order to create the folder, instead of using the UI, here I'm writing at the code level so that I'll be creating the folders and the file structure as per my preference. Now, after that, I'm making use of an image, like I'm making use of Matplotlib library to understand how does the data distribution would look like. So let's wait for it to execution to complete, and then I'll explain what is happening and we'll have a better idea what is the kind of data that we are dealing with. Okay, so we have these various set of images with me. I have COVID-19 related images like lung images. I have close to 4,000, and lung opacity I have 4,000. Normal I have 10,000 plus images, and for viral pneumonia I have close to 1,000 images. That is what I could observe from this bar chart. Now what I'm going to do is I'm going to divide this data set. So I'll first set the curriculum. So this is how like can think of when I say training the machine learning model. I'm just said differentiating what will be my training data, what will be my validation data and test data. So this is just for my model. So I'll train with my training data. I'll validate with my validation data. Once the model training is complete, I'm going to do the evaluation with the test data. So I'll just separate the data which I have with me. So I'm making use of Python's OS module to perform all this activity, and where I'm actually working with files and directories. And after that, I'm setting the path. And here I'm just making use of TensorFlow library. Okay, so this is another library where I'll be using it to build a neural network. I'm going to create a data generator. And after I create the data generator, so here it is going to flow from the directory. Okay, so I'm just going to create the data generator. Now after this is done, if I display first few images, I'll just come below and I'll show you how the images would look like, a sample image. Okay, a sample image will look like this. So I have the images right here. So these are the some of the images that are belonging to normal, some of them are COVID. So this is how the various images that I have with me. Now what I'm going to do is I'll use these images and I'll show it to my computer, and my computer, in the sense in this scenario the deep learning model. Okay, so once it finds the same, next I'm going to build the model architecture. So here I'm building the architecture. This is my input image. From this we are going to, like, once from this image I'm going to process the image. I'll apply various CNN model layers and followed by pooling, CNN pooling, so convolution, ReLU, max pooling, and fully connected, and so on. So I'm making use of a pre-trained layer. So when I say pre-trained layer, it's a model which already has been trained. Okay, so you can think of something as, like, let's say if you want to prepare pizza, so what you would do, you'll just get the like pizza base from outside shop, and you'll add the topping and you are going to prepare the pizza, right? So in the same way here, when I'm building my neural network, I'm getting the model from the library itself, which has been already trained. On top of that, I'm going to send in my data, and that model is actually the VGG16 model that I'm getting. Once I get the model, I'm performing the application of this model. So I have developed the model, and here this is called as a compilation step, where I'll compile my model and we'll define some settings for the model so that it can learn properly. We'll perform the fit, and I'll just come down, guys. If I simply come down here, I've given the data. So this is the data where the image belongs to the person who is suffering from COVID-19. And when I gave this image, my model is saying it as the chances of image being COVID-19 is 100%. So this is for you to demonstrate that how we can make use of deep learning and perform this activity of COVID detection using chest X-ray. Now what I'll do is I'll execute this cell so that it can perform the training. Thanks a lot, guys. I'll be ending the session. So I look forward to seeing you next time. Take care.